The next one that we're going to look at is what's used in the Toyota range a little bit. It has an internal coil, but it also has two internal inductive pickups. Because it has an internal coil, the top of the coil tower comes out here. There's a little bar that goes across here and sits on top the carbon brush. The carbon brush then sits on top of the rotor button and allows for distribution of the high voltage. Because this is an inductive system, we don't even have to power it up. We don't even have to have it attached to the car even. The ignition coil's been pulled off, shoved out of the road, and the main thing is that we're going to focus on is this wiring loom here. Remember, for an inductive generator to work, it has to have a magnet in some shape or form, and then a tone ring that goes across it, interrupting that magnetic field. So in theory, this fella down here should possibly be a magnet. Check that out. That's just got him. And then there's another one over the other side. I think that's down there somewhere, and that's a magnet as well. Oh, here it is over here. Okay, so both magnets and two tone wheels, as I mentioned. This one has 1, 2, 3, 4, and this one has a lot more. I'm not exactly sure how many are on there, but we should be able to figure that out when we hook up our oscilloscope. Here's the basic wiring diagram that we're looking at. Toyota call them pickup coils, coil generators, inductive pickups, the list goes on and on. The important thing is that they are self-generating voltage. We have a look at G, it comes up here, goes around and down to G1. But the earth is connected to NE, which is our second coil of wire there. You can see how many turns are on this signal rotor in comparison to that signal rotor. If we were able to count the amount of teeth on this, that would tell us how many degrees that each teeth is worth. This signal here, IGT, controls the negative side of the ignition coil. That's the one that actually does the work. So it gets the information from these two here, the crank position and crank speed. AC voltage produced by this coil together with this coil is sent back to the ECU. That information is processed within the ECU together with information gathered from other sensors, and a decision is made when the ignition coil should be fired. That precise time is sent to the IGT connector here at the igniter, which is probably just a basic MOSFET. That triggering allows high current to pass as the negative side of the coil is opened, allowing mutual induction to take place and a high voltage from the secondary to pass through to the spark plugs. This fella over here, the IGF, was fairly uncommon back in the day, but fairly common nowadays. It's actually a feedback circuit. So in other words, when the IGT in the ECU triggers the igniter, which in turn fires the ignition coil, allows high voltage to go to our spark, that in turn allows a feedback circuit to go back to the ECU that will tell the ECU if the spark plug fired or not, and therefore it can do misfire counts. It can also put on the check engine light, etc., because it knows if it fired or if it didn't. I actually didn't even bother with the wiring diagram. If you think about it, it's a coil of wire. It's got to have continuity through itself, doesn't it? One measured about 200 ohms, I think it was, and the other was 600 ohms, something along those lines. But yeah, easy to hook up, no problems. So you can see I've just got the oscilloscope probes hooked up. A earth joins two together and the others are individuals. So all I'm going to do now, remember there's no power going to it, I'm simply going to turn the distributor. Right, let's turn that rotor and see what happens there. Nice signal, you can see two clear distinct signals. Okay, let's have a look at them a little bit closer. You can clearly see two distinct signals on the pattern here, can't you? The blue trace, and as I mentioned, as we rotate it, it goes to a positive, then it comes down to a negative, positive, and then negative. Same with this other bloke in the background. Now what I've done is I've divided it into 360 degrees, so you can clearly see the main tone wheel is putting out 1, 2, 3, 4 signals, isn't it? The secondary one, which would be position, would be doing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4 times by 6. 6 fours are 24. Is that correct or not? Let's count the wheel. You can see there's a little tiny dot here, and that most likely indicates number 1. So I've just put a white mark there as we can see them. So let's count them off. Let's count them, Jim. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So, proven just by the waveform. Remember, this is an inductive generator and it has no voltage going to it. It is self-producing voltage simply by having a tone wheel of some description passing a magnetic field down here with a coil inside. Pretty basic, easy to test.